The Faraday program consists of a few major parts: the menu and toolbars on top, the model and graph windows in the middle, the message area, the command line, and the status bar on the bottom, and model tree and search on the left. To perform a simulation using Faraday, you must first construct a geometric model of the physical system. This can be done using the built-in geometric modeler or by importing geometry built using commercial eddy packages. To demonstrate the basic setup and analysis features of Faraday, a step file is imported. You can see geometry summary information in the message area. The units are set U from the model tree or from Utilities menu on top. Geometry objects are set U for easy labeling and selection. This dialog can be opened using the toolbar or the model tree. Clicking the Create button 3 times will create 3 generic objects with random colors, no assigned geometry, and sequential names of Object 1, Object 2, etc. Object names can be renamed as disk, inner coil, and outer coil. Check the selection type is set to volume. Select the Add Volume button to assign volumes in the model to the objects. The key properties generally needed in eddy current models are the frequency of operation, materials, and currents. Select the magnetic setting dialog from the physics menu to set the operating frequency. Faraday has 3 operational modes, the default mode being the harmonic or single frequency. The default value for frequency is 60 Hz. In this example, we will not change the default frequency. The other 2 modes of operation are static and transient modes. In the static mode of operation, magnetic models with coils carrying steady currents and permanent magnets can be solved. In transient mode, models with arbitrary current shapes for a finite duration can be solved. Open the material table from the physics menu, select aluminum, and assign it to the disk, which will be highlighted in green, and then mouse is right-clicked to end the selection. Save your model. To assign volume current to the coils, select Add Current Source from the physics menu. Set the selection switch to volume. Verify Active Radial button is set to on. Set the value type to volume total. Check only the phasor box and enter 9,180 amperes for 0-degree phase angle. Click the plus button on bottom for forward definition to add volume of outer coil to the current values. The mouse is positioned over the coil volume and clicked. When the object appears green, mouse is right-clicked to end the selection. Faraday prompts you to select the input surface for current. The sewer is selected, and current is assigned to connected volumes of the coil. Now you can notice the IDs of the 4 volumes of the coil assigned with the current. Also, this current source was given a default name, Current Source 1, and color blue. If you want, you may change the name and the color allotted by the program. Click on OK button of the current source dialog box. Similarly, 18360 amperes for 0-degree phase is assigned to inner coil. Note that the current assigned in the inner coil must be in the opposite direction to that of the outer coil current. Note that from physics applied in Model Tree, when the current source of a region is clicked, that volume will be highlight orange in the model. You can edit it by right-clicking on the current sources. The model is now ready to solve. Next, outputs are set up from the Define Output box under the Solution menu. Click the Add Plot button at the bottom to open the Plot Properties dialog box. Select the Arrows tab. Set the field quantity to B field and location to On plane. Type -105, 5, -105 on the command line and press the Enter key. Type XYZ on the command line and press the Enter key. Type XYZ on the command line and press the Enter key. The interface will return to showing the Define Output dialog, but with one defined plot. Now, J-field contours are defined on the inside disk surface that was exposed by hiding two of the volumes. Next, open the measurement editor from the Measurements button on the Define Output dialog. Click on the Add Measurement button to set up force volume measurement on the disk object. Close the measurement editor and define the output dialog. Now all the outputs are defined. Save the model. From the Solution menu, select Run Solver. When the solver is finished, the Output Manager box will appear. The presentation of the plots can be customized by selecting the properties of the plots in the Output Manager box. We can improve the solution with local refinement. There are many ways to accomplish this. For example, if you would like to improve the whole solution, Solution then Refine Solution is the best method. If you are interested in a local area, tell Faraday to put more weight on the solution quality in this area. This sample session has introduced basic techniques that you can use to perform Faraday simulations when beginning with a CAD model.